Alrighty, in geometry section 1.4, it's all about measuring angles. So let's first start with the definition of an angle. So an angle is formed by two rays with the same endpoint. The different parts of an angle, so the rays are the sides and the endpoint is the vertex. So if we have an angle, this is a side, this is a side, and then this point right here would be your vertex. Okay, so you can name angles a few different ways depending upon what the angles are and how it's labeled. So you can name it by its vertex sometimes. If there's only one angle listed, you could name it as angle A. And yes, you do have to have that angle sign. This little thing right here looks like a less than sign kind of. And then another way to do it is a point on each ray and the vertex. So on this one you can name it BAC or CAB, but the A always has to be in the middle. Or if there's a number, like this one has a number in it, you could name it angle 1 because it's listed on this one that way. All right, so on this one in the diagram, AB are the sides and A is your vertex. So on this section right here, what are two other names for angle 1? Well, you can name it, it's this one right here. So you could name it angle, and yes, you need the sign, JMK. And then the other way you can just switch it, but the M still needs to be in the middle. So angle KMJ. All right. The next one. What are two other names for KML? KML right there. So you can just switch the L and the K. M still in the middle, so LMK. Or the other way would just be by that number, which is listed angle 2. Okay, let's move on. Would it be correct to name any of the angles angle M? Explain. So think about it. Could you just say angle M and know which one I'm talking about? So the answer is no, because it could be, let's count how many different ways it could be. Okay, it could be this one, it could be this one, or it can be those two together in green. So it could be 3 different angles. So that's why we can't, because it's not specific enough. Okay, let's move on. So if you hear interior, you think inside. So interior of an angle is the inside of the angle. And then exterior is the outside. When you think of the exterior of like your house, the outside of your house. So another way to measure the size of an angle is in its degrees. So to indicate the measure of an angle, write a lowercase m, so that means the measure, in front of the angle symbol in the diagram. So like the measure of angle A is 62. You write this as m, angle A equals 62. So we're only working in degrees. You can also work in radians, but we're not doing that. So a circle has 360 degrees. And so 1 degree is 1 over 360th of a circle. A protractor, this shape right here is a protractor, that half circle looking thing. It forms a half circle and its measures go from 0 to 80 because 0 to 180 because half of 360 is 180. All right, we have a postulate. So the protractor postulate. So consider the ray in blue, OB. That's the bottom ray. And a point A on one side of OB. Every ray of the form OA can be paired with one of the real numbers from 0 to 80. So from 0 to 180. So So how you use these is you have two different sets of numbers. You have the outside set. Actually, let me highlight it. So we have the outside set right here in yellow. And then we have the inside set in green. What's cool about this is you can go either way, but you just have to be consistent on what you do. So if you are right here, this number right here, to me, it looks like it is 55. And I'm going to go off the yellow. So from 55 over here to B, which is 180 on the outside, we're doing the yellow. So what is the distance between 55 and 180? Well, you subtract them. 180 minus 55 would give you 125. So the measure of angle AOB is 125 degrees. Because that's what we thought. And does that make sense? Well, 125 degrees is an obtuse angle, and they give us an obtuse angle. So that works. If I was doing this problem in the green, so right here in the green, it looks like that's at 125. And in the green, this is 0. So what's the difference between 125 minus 0? Well, it's just 125. So you could do it that way too. It just depends on which way you see it. Either way, you'll get the right answer. Some are easier than others, just kind of depends on what you see. And then here is that protractor postulate that I just showed you. Allows you to find the measure of the angle. So I should have used absolute value on this point right here, but I did not. So this is just like this segment addition postulate. You have to take the absolute value because you're talking about distance. So you're going to be having positive angle measures. So on this one doesn't line up perfectly on a 0 or 180, so we have to do a little bit of work. So the formula is right here. We're going to have the absolute value of something minus something. Let's use the outside measurements. So it looks like that's 45. And this one's a little bit trickier. It's kind of in between 145 and 150. Let's say 147. We'll use whole numbers to make it a little bit easier. So to figure this out, we're going to do the absolute value of 147 minus 45. If you stick that in your calculator, you get the absolute value of 102. So the measure of angle COD is 102 degrees. Okay. What are the measures of, so this next part, if you want to pause the video and try it by yourself, you definitely can. So what are the measures? Actually, I'm sorry, I'm going to pause. I forgot something, this part right here. So here's all the different kinds of angles that we're going to be talking about. We have acute angles, which are smaller than 90, so they're between 0 and 90. A right angle, which is 90 degrees, and you see that little right symbol, that means right angle. Obtuse is between 90 and 180. And then a straight angle is a straight line, which is 180 degrees. All right, let's go back to this. So what are the measures of those three angles? So we're going to have that. Sorry, I'm struggling. Okay, so we're going to have what are the measures of this angle, and this angle, and then classify each angle. So we should have 6 total answers. So let's first start with the measure of angle LKN. So LKN is right here. LKN looks like it's going to be obtuse, but let's just wait. So we have the formula, which is the absolute value. The absolute value of something minus something. You can use the inside angles or you can use the outside measures. It doesn't matter. Let's use the inside ones on this one. So it looks like we have 100 and what would that be? It's kind of hard to see. I prefer to use the outside angles. Looks like 155 or 145, sorry. 145, it's right in between 150 and 140. And then the other one, the inside is 0. That worked out nicely. So we have the absolute value of 145. So the measure of angle LKN is 145 degrees. So there's one answer. What type of angle is that? Well, it's obtuse. So that's the other answer. So this one has two answers. All right, now let's do the other angle is the measure of angle JKL. So JKL, get all this erased. Okay, so we have the absolute value, JKL. So J looks like it's at 90. So the absolute value of 90. Can you tell I'm having technical difficulties today? Because I am. So the absolute value of 90 at J minus L. So we can either look at the inside or the outside. I'm going to look at the outside. So 90 minus 35, absolute value. That gives you 45. Nope, I was wrong. Sorry, 55. 55. So the measure of angle JKL is 55 degrees. And that would be an acute angle. So there's that answer. I'm going to switch colors. Last one is the measure of angle JKN. So JKN looks like J is the absolute value of J, so that'd be 90. K and then N. So N is going to be 180. So this is 90 minus 180 is negative 90. So the measure of angle JKN is 90, and that would be a right angle. And there is your answer. Those are your three different angles and their classification. Okay, let's go on to the next page. So now you see that word congruent again. You see it a lot in geometry. Congruent, remember, means equal. Their measures are equal. Still is the same symbol, an equal sign with a squiggle on top. So if you see the word congruent angles, think they are equal. Okay, so now we have the angle addition postulate. It's very much like the segment addition postulate. So on this one, the measure of AOB, so AOB, plus the measure of BOC equals the whole thing AOC. So those two pieces equal the total piece, one whole piece. All right. Now we get to do these fun graphs. So FXH is 130 degrees. Let's label that. So FXH, that is going to be 130. And then FXG, I'm going to switch colors here so we can see. FXG is going to be 49. Okay, before we start solving anything, can you tell right off the bat what some angles are? Well, hopefully you see this one right here. And the reason I say that is because it has those lines that tell you they are congruent. So this one must be 49 degrees as well. Okay, so the first problem is wanting us the angle FXG. They give us that. Oh, it's congruent to. Sorry, that's the congruent. So which one is that congruent to? Well, I just told you. It's congruent to angle IXJ. All right, the measure of GXH. So GXH. So that would be this one. Well, we're gonna have to do a little work on this. So if we know this whole thing in the green is 130, and then that piece right there in the red right here is 49, well, that we use the segment addition postulate. So you're gonna do 130, the absolute value 130 minus 49. What would that be? 81, I think. Sounds right. 81. And so we have this one would be the measure of angle GXH would be 81 degrees. Name a straight angle in the figure. I'm going to skip that one for now and go to the IXJ. IXJ. Oh, we already did that one. So that would be this one right here in the red. That would be 49 degrees. Okay, let me erase this so we can see it a little bit better. So we have, name any straight angle in the figure. What's a straight angle? Well, it's a straight line. So you would do angle, there's a couple different options. You could say this one right here would be FXI or IXF. Or this one right here would be angle GXJ. So, or JXG. Okay, now let's do this one. If the measure of RQT, so RQT would be the whole amount, is this, what are the measures of the measure of RQS and the measure of TQS? So this one, if you have that's the whole amount, well this plus this would have to equal that whole green amount. So let's go ahead and write that out. We have 4x minus 20 plus that blue amount, so plus 3x plus 14. All of that is going to equal the whole amount in green, which is 155. So let's go ahead and solve it. Combine your like terms. So that'd be your x's, so that would give you 7x. Bring everything else down. Combine like terms again. So negative 20 plus 4, different signs difference, give you negative 6 equals 155 plus 6 plus 6. That would give you 161. So 7x equals 161. And then we are going to divide by 7, stick it in your calculator, or do long division if you like to. So x equals 23. But what is the question asking you? Well, it's asking you what's the measure of this and the measure of that. So we have to plug in that x into the equation, the original equation. So let's find the measure of RQS. Measure of angle RQS is going to be, is 4x minus 20. So it'll be 4 times 23. Oops, 23. Let me write that a little bit better. Times 23 minus 20. Stick that in your calculator, and you get the measure of angle RQS equals 72 degrees. Does that look realistic? Yes, it does. So let's move on. Then we have the blue part. So the measure of angle S, I'll write it like they do, TQS. So TQS, they said, was 3x plus 14. So now we're going to substitute in that 23 for our x here. 3 times 23 plus 14. Stick that in the calculator, and you have the measure of TQS equals, it'll be 83 degrees. All right, and then now here's a quick way to check our work. So if we have the red angle is 72 and the blue angle is 83 and the whole green angle, the two together, is 155, we should be able to add them together and get 155. So it should be 72 plus 83 equals 155. And yes, it does work. So 155 equals 155, so check, that works. Okay, the next problem. If DEF is a straight angle, so if you think straight angle, think 180 degrees. What are the measurements of DEC and CEF. So we have two questions that we're trying to answer. So DEC, so the whole thing is 180. I'll do that in green. The red angle, DEC. So let's do measure of DEC. Measure of DEC is going plus the measure of CEF should equal 180. So let's solve it. We have DEC is 11x minus 12 plus CEF is 2x plus 10. All of that equals 180. Let's solve by combining your like terms. You have 13x minus 12 plus 10 equals 180. Combine like terms again, that would be negative 2. So 13x minus 2 equals 180. Add 2 to both sides, and you get 182 equals 13x divided by 13, and x equals 14. Okay, so x equals 14. So now we got to plug it in. So let's do DEC. So DEC is 11x minus 12. And then, so it'd be 11 times 14 minus 12. So the measure of angle DEC is going to be, stick that in your calculator, and you get 142 degrees. All right, let's do CEF. So CEF is going to be 2x plus 10. We plug in that 14 for our x. So 2 times 14 plus 10 would be 38 degrees. So the measure of angle CEF equals 38. So we've got that answer, and we have our other answer. Good, we have our two answers. Let's quick, real fast, check our work. So for checking, the two together should equal what? 180. So 142 plus 38. Yes, that would be 180. So 180 equals 180. Check, we did that right. All right, two more problems. So JKL, the angle JKL is a right angle. What is the measure of JKM and measure of MKL? So together, these two are 90. So we should have, we're trying to figure out two answers. So we have JKM, so angle JKM plus MKL, angle MKL. All of that should equal 90. So let's plug in our pieces. We have JKL is 12x plus 3. And MKL is 6x minus 3. All of that equals 90 still. Now let's solve it. Combine your like terms. Gives you 18x plus 3 minus 3 equals 90. Well, now we combine plus 3 and minus 3, that's 0. So we have 18x equals 90 divided by 18. So x equals 5. So we get that answer, but that's not what it's asking us. We have to figure out what JKM is. So let me draw a little line. So the measure of JKM, and JKM we said was 12x plus 3. We're going to plug in 5, so 12 times 5 plus 3, I believe, is 63. So the measure of angle JKM is 63. Let's check, or let's find out the measure of angle MKL. Would be 6x minus 3. Plug in 5 for my x. 6 times 5 minus 3, 30 minus 3, so 27. So the measure of angle MKL is 27 degrees. There's our other answer. Let's do a quick check. So check 63 degrees plus 27 should all equal 90. Yes, it does. So 90 equals 90, check. That one is correct. Alrighty, last problem. Sorry this video is so long. So we have the measure of DGE equals 3x minus 5. So this is 3x minus 5. And the other one, EGF, is 2x plus 10. This one we just have to solve for x. What do you know about these two angles? Well, you can see from these lines right here that they are equal because they have those congruent symbols. So if the angles are equal, what do? Well, we can just set an equal sign in between them. So 3x minus 5 equals 2x plus 10. All right, get everything on one side, or the x is on one side, so I'm going to subtract 2x from both sides. X minus 5 equals 10. Add 5 to both sides. X equals 15. So lucky, we only had to find one thing on this problem, x equals 15, and that is it. Alrighty, thank you guys for watching and have a great day. Oops, what did I do?